Okay, hello and welcome. Today we're going to be covering Grashof's criterion and what it means. Okay, so what is this? What even is this? Okay, well, it's a principle we use in kinematics to determine the rotational behavior of a floor-bar mechanism. Okay, and if this criterion is satisfied, it's said to be a class 1 kinematic chain. So what does it all mean? What does it mean? What is the actual criterion? Well, let's go over it. Okay. So criterion is as follows. If S plus L is less than that of P plus Q. Okay, what do all these mean? So S is the length of the shortest link in the mechanism. So we call this shortest. L is the length of the longest. And P and Q are the lengths of the two remaining links, okay? So if the summation of these two, the smallest and the longest, or shortest and longest, are less than the summation of the remaining two, it's said to satisfy this criterion, which means a class 1 kinematic chain. Okay, what that means is that all inversions of the class 1 kinematic chain, are said to be that at least one link in the mechanism undergoes full rotation. Okay, what does that mean? What is inversions? So a kinematic chain is a chain which you have all these links that are connected together, and you haven't specified the ground yet. And by specifying the ground, you can have these different inversions. Okay, so let's say I have some ground for a mechanism. Okay, I guess pretty viable. We'll just work with it. 3, 4. Okay, let's say it's my ground now. Okay, it's my ground. For me, it's my ground. Okay. Now, this will be one inversion. This will be two inversion. So this will be one inversion. So this will be the original. This will be one inversion, two inversion, three inversion. So each mechanism is said to have n minus 1 inversions, where n is the amount of links. That makes sense, right? Because let's say I have n links, I can only have n minus 1 amount of inversions because the original one has already been occupied in a sense. So let me explain that real quick. So you have, let's say you have this, okay, right here, right here, right here, okay, and this is grounded. This link is grounded, okay. So this link. So 1, 2, 3. Sorry, it's kind of like this. 1. So also 1, 2, 3, 4. 4-bar mechanism, okay. This is already grounded, so this is our original one, right? So the only possibility that we can ground other ones are this one, this one, this one. Just 3 possibilities. That means we're gonna have n minus 1 inversions, okay. That makes sense. Okay. Now let's go back to what I was talking about. Okay. So class 1 kinematic chains is the one that satisfies the Grashof criterion, which is S plus L is less than P plus Q. And every inversion is said to be that at least one of the links in the mechanism undergoes full rotation. Okay, let's look at this now. There can be two links that go under full mechanism. Sorry, full rotation. There can be one link, and the behavior of it, how is depicted on which one is grounded and stuff like that, and which one is the shortest, whatever. Okay. Now this one recognize. You guys can guess, it's a crank rocker, okay? So we have our crank, we have our connecting rod, we have our rocker. So the crank undergoes full rotation, okay? So let's say this is a class 1 kinematic chain, so it satisfies this equation. So let's say it's the shortest one, okay? Longest one can be added, doesn't matter, okay? So the inversion for this, for you to achieve a class of, so for you to achieve a crank rocker, is that the link that is adjacent to the shortest link has to be grounded. So like you want either this one or this one. And as you can see, this one's grounded and this is the shortest one. So such that as long as this is first satisfied, and secondly, the shortest link has one adjacent to it that's grounded, okay, that means what? That means that it is a crank rocker. So this one rock, this one cranks full rotation, and this link, it oscillates between two extreme values. It rocks, okay? Now this one is a rocker rocker, okay? So again, we're going to achieve this value right here, okay? Let's say this statement is true. Now what you have is okay, these two. How do we achieve this inversion, okay? Now this inversion is such that this link over here undergoes forward rotation, this one. So this link undergoes forward rotation. So if you follow this link, it undergoes forward rotation, okay? How do we achieve this inversion? If the link opposite to the shortest is grounded. So as you can see, this is the shortest link, S for shortest. This is grounded, you can run my lines here for grounded. The link opposite to the shortest is grounded. If that's your inversion, okay, that means that you'll have two rockers, rocker, and these two rock or move between two extreme positions. I can see here, okay? These two extreme positions will go like this, okay? And it goes like this. This, however, undergoes forward rotation because it still satisfies this rule. So once again, if Grashof criterion is satisfied, we have a class 1 kinematic chain. That means that at least one link in the mechanism undergoes forward rotation. To achieve rocker, the link opposite the shortest is grounded. That means you have this. So every inversion that satisfies first of all this and has the link opposite the shortest is grounded is said to be a rocker. Okay. Next one we have drag link. Okay. Drag link is when you have two links in the forward mechanism that undergo forward rotation. So you have this one and this one. Okay. This is very simple. Again, class 1 kinematic chain, because first of all it satisfies this. Every class 1 inversion for you to achieve drag link has to be such that the shortest link is grounded. That's it. Okay. If, for example, let's say you have S plus L is greater than P plus Q, so this summation of the shortest and longest is greater than the two remaining ones, you have a class 2 kinematic chain, which means that every inversion is thought to be you could say a triple rocker. In text is different from different terms used to do it. Basically, it's saying that it just rocks. There's no link in the mechanism that undergoes forward rotation. If this is true, this is true. Basically, it does not satisfy Grashof, and every inversion is said to be a triple rocker. So they all rock. Okay. Now, as I said before, this rule is used to determine, basically determine whether a link undergoes forward rotation. It determines the behavior of the mechanism, helps determine the behavior of the mechanism. But it's independent from mechanism inversion, okay? So we can determine whether one undergoes forward rotation based on Grashof criterion, and based upon the lengths of the mechanism where they exist and stuff like that, and if they're grounded or not, then we can determine whether or not which kind of mechanism it is, okay? So that's it for today. It's very simple. If you have any questions, please let me know, and that should be all. Bye guys.